parts anyway, so you can see how it's done.
do dynamics first.
So the difference with the exam that's in 2 weeks' time, 2 weeks time, right? Just in case you didn't know. The difference is that you only need to choose out of 4, choose 3. Alright? So over here, I make you kind of try everything. And the other difference is that these simulated questions, you can see that there are only kind of like a few parts, yeah? But in your real exam, it's a lot more parts. Okay? In fact, this paper you should have completed within 1 hour. Yeah? If you were to do 3 questions. Right? So the length of your script, right, is going to be 2 hours, and then you get more parts. So, well, the good news is that you wouldn't be so cramped during the exam. You'll be sitting over at, I think, some of these guitar rooms, just right over there. So each of you will get 1 table. Okay? So it's not going to be that crowded. So if you find that this simulated paper has been a mind blower, okay, don't worry. Form study groups and then work hard together. Okay, especially if you find that actually when I set the simulated exam paper, I was actually sitting most of the time, just sitting. So if you find that you're just sitting and not doing, you need to form a study group. Okay, form study group, help out each other. Amongst you, there will be some who can do it. Okay, so why not help out each other? And if you cannot, then all of you want to attend you. And the other advice is that there's a strong correlationship between those recipients, so students who come for receipt, to did they attempt the practice question or not. Right? There's a strong correlationship. So if you practice questions, then there's a lower chance that you need to go for receipt. Alright? So year on year, that is the correlation. I think it's not about is the practice question very similar to exam question. It's not about that. It's about that you are able to think and do and go through it. It's that attitude, I think. Right? So attend your practice questions. Alright? So I'll try to answer the topmost question that all of you would have in your mind. That is, hey bro, is the exam just like that? Well, actually, my answer is that I cannot tell you anything about the exam. I cannot. Right? Why? That's because you earn your degree that way. Right? That is your capability. You earn it. Okay? So let's have a look. This question. Now the marks allocation may not be exactly what it is during the exam, since the exam has 4 parts. But if you notice, each of the questions, right? This one part A, part B. All the questions, 4 questions, each question amounts to 15. In your exam is 25. That's why I said there are a lot more parts. Okay? So if you have been wondering, like, wow, in the lecture, oh, you write so fast. Yeah, I'm training you. Yeah. You need to write fast. You'll find that you don't have enough time. Okay? You need to achieve that. How to do that? Do your practice question. So this question is interesting because this is your motor, right? It's your water. And if I were to sketch this as your water line, and if I were to ask you this question, where do you think the center of gravity is? Is it above or below the waterline?
See how I understand.
It cannot be above. If it's above, then center of gravity will just topple down. There's no way for the center of gravity to be above the waterline. Try it. You have something heavy at the top, put it in the water. That heavy part, of course, will just topple around. Then you'll settle. So your center of gravity is always going to be below the water level. Okay? In its steady state, static state. So you got to use that what you have seen before. This is your center of gravity symbol, right? Kind of like sketching that way. So this displacement is x, and the whole thing is of h height. So it's same as a cylinder, right? That cylinder. So this is a cross section of that cylinder. You'll find that the area of that cylinder, this surface here, wasn't given. Right? But anyway, later on you get to see that you cancel off. Right? It doesn't matter. But I can assume it to be area A for now. So this area over here, area A. So if I were to displace it, so if I were to displace it, so now that cylinder gets lower. And displace it by how much? This is the centroid. So displace that centroid now is over here. So this much, I displace it by x. And if I were to displace it by x, I will experience a force, that buoyancy force, right? Just like any kind of a cylinder, if it's floating naturally, if you press on it, you can feel that it's actually pressing back on you. So there is that buoyancy force. I call it FL. The L stands for the liquid here. So what I need is that eventually I need to establish the F is equal to ma sort of equation. That's a Newton's second law. Summing up all the forces equal to the mass multiplied by the acceleration, which is x dot dot. So that mass, F is equal to ma, that mass over there will be the mass of the solid. Yep. Mass of this solid structure, cylinder, solid cylinder, that I call ms. So mass, for this kind of structure, you're actually given the density of the solid. So what do you think the mass would be? Mass is equal to density times. I learned it this way, and the mass is density times volume. So the density is rho solid, right? I'll just write S instead of the whole word solid. How about volume? Volume of cylinder would be?
Area times height. AH square.
If I let this just be A, that surface over here, this, so area times H. Yep. So if the mass has been pushed down by x, a displacement of x, then that buoyancy force, FL, will be equal to mLg. And if you're not familiar with this, this is Archimedes' principle. Remember your physics, Archimedes' principle? That amount that it displays, right, is the force, right? That lift force. That's why your boats float here. Yeah, now it's coming back. If it's not coming back at all, here it is. Yeah. So mass of that liquid that has been displaced, right? It's not mass of the it's not the mass of the cylinder, but that much that you press it down. So mass again is density of the liquid multiplied by that volume of the liquid that has been displaced. So what would that be? Rho A N that volume. It's not H, right? You only displace it by X. Yeah, so it's X. This is your ml and then G. Okay? So if you are able to get that, 1 mark. Yeah. So this figure, there's no marks allocated to it. It's not necessary. Right? It's too simple. Yeah. So now the Newton's second law says that summing up the forces, so this is your free body diagram already. Summing up the forces along x must be equal to the mass times acceleration. What mass do you think this would be? Would it be ms or ml?
ML.
ml? ms? Alright. It is the whole object that's moving, accelerating, right, in its dynamic form. So you must consider the whole thing. It's not that mass of water that has been displaced. So this one is ms. So the rest of it you can solve, right? Okay. Summing up the forces, you only got FL. Right, FL is pointing upward, right? It's pointing upward against your convention. So FL is minus rho L AX G must be equal to this MS will be rho S AH X dot dot. So the area you can cancel off and then adjust everything to one side. So you have rho S H X dot dot plus rho L G X equal to 0. And you can divide throughout by X dot dot. So you get rho L G over rho S H X equal to 0. This one will get you 2 marks. So this is quite straightforward already. Where do you think is omega n? Like this whole thing over here. How do we know that is omega n? Because from your data sheet, in order to find out your omega n, this is part here. Right. For a bent second order system, you can see that this x dot dot here, the x dot dot here must be equal to 1 before this part over here that's beside the x can be considered omega n squared. Right? So this is your omega n squared, not this part here. So you got to divide throughout so that this is 1. Okay. That's how it came about. So that means your omega n will be equal to square root rho L G over rho S H radians per second. 1 mark. So if you solve everything but forgot your radians per second, then you lose that 1 mark. So because omega n is equal to 2 pi Fn, So you can find out what is your Fn. That is 1 mark. Right? So that part is expressing the natural frequency in hertz. So you must have hertz over there, or else you lose that 1 mark. Okay, part B. So for part B, is very similar. The principle is very similar. So for part B, I'm going to sketch it out as well. So it says that there's a uniform tube, so you just need to sketch that uniform tube, and then the bottom end of it is closed. This base is closed. And this has been weighted, right? So the question says that it has been weighted so that it floats upright. Okay? So it floats upright in that way. And in this state, is immersed up to 0.3 meters. Again, that surface area is A. But this is not the free body diagram, so if you sketch that, you wouldn't get any marks. The free body diagram is going to look like that. When you press it down, if you press it down, it will go down, and then release it, and then it will oscillate up and down in that way. Okay? So when you press it down, it will go lower. And just like just now, you will have that force due to the fluid that you displaced. This is your x direction. And the question says that you will experience heavy damping. So that heavy damping is going to be that way, Cx dot. If you're able to do this, 1 mark. A very simple free body diagram. So let's find out the mass. The mass of this object. So the mass will be equal to rho A, and in this case 0.3. Right? The part that's submerged. So summing up the forces, you have that Cx dot that's in the opposite direction, minus Cx dot is FL. FL will be rho AXG, the whole thing equal to 0.3 rho AX dot dot. So you can express x dot dot as a subject, divide throughout by this coefficient, and you'll get x dot dot plus c over 0.3 rho A, x dot plus rho AG over 0.3 rho AX equal to 0. So this we can cancel out. So some of you were asking, that G over there, what value would it be? Normally I use 9.81. Sometimes I find Glasgow they use 10. Right, so it can be either one. Okay. So I kind of mentioned this before already in class. Yeah. So that means this part over here, your omega n is equal to square root G over 0.3. And G over here, I take it as 9.81 meters per second squared. So you just solve that, 5.718 radians per second. So forming up this equation of motion is 2 marks. This one is 1 mark. So the question says this kind of words here that some of you may find it hard to understand. So yeah, I'm gonna move a little bit down. This part here, same side of the mean. Mean here means steady state. Alright. So same side of the mean, it will oscillate with a maximum, consecutive maximum displacement, 10, and then the next one is 1. So what that sentence is trying to say is that your oscillation is going to look something like that. You press it down, so you will start from below, and then you will oscillate that way.
Can you stand?
Yeah.
Okay.
So this part here will be units of 10, that part there, units of 1. AB dented. Same side of the mean, so the mean is here. This is your mean. So instead of steady state, that's the English. That way, same side of the mean. So it wants us to find out, determine the logarithmic decrement. So you have seen it before. In fact, in your data sheet, I sort of wrote it over here. It's also in your Moodle. Logarithmic decrement is equal to this, but you wouldn't be putting in this. You'll be putting in this because they're equivalent. Right? So ln of that 10 over 1. Right, exactly 1. Yeah. It's so simple, right? Yeah, I know. It's ln of 10 over 1. And logarithmic decrement. Right? Is ln of 10 over 1. So that's 2.302. And this will get you 2 marks. Right? So since this is also equal to 2 pi zeta over square root 1 minus zeta squared. So you can find out what is zeta. So zeta is equal to 0.34. What does it say? 0.34. It is underdamped, overdamped, critically damped system. Which one? For zeta that's less than 1, this is an underdamped system. Yep, so that's why when you press it down and release it, you'll go up and down. Right. And underdamped system. So the rest of it, it wants you to find out what is omega d. And what is tau d. Right, so you will have your omega n and your zeta already. And then with the omega d, you can substitute in here, and then you can find it out. So this part, 1 mark, 1 mark, 1 mark. Okay, I'm not going to solve it, so you get a chance to solve it. So question 2, explain what does it mean by rise time, and then maximum overshoot. So this one was one of the past year papers that I put it in. Okay. To 8. So for rise time, if you were to sketch in that way, if you were to sketch this way and then say, hey, this is rise time, you don't get any marks because it says explain, right? Not sketch. Yeah. So if you don't explain but sketch, then you have not answered the question. Yeah. So maximum overshoot is here if you just label and say, hey, this is overshoot. And I know it's maximum overshoot. Yeah. This is labeling, this is sketching. The question did not ask that. Yeah. So then, how to explain rise time? Rise time is a time taken to first reach the final steady state. Right? So the keyword that I'm looking for is that you understand that it's time, and you understand that it not only reach but first reach. Right? So if you miss out some of these words, and I need to have a look, how far are you? If you just say time taken to reach steady state, then actually there are a lot of it. Right? There are a lot of it. This part here, these are all the time that you would take to reach steady state. So which one? So maximum overshoot. If maximum overshoot, you would use the word time, that is wrong. Maximum overshoot has nothing to do with time. It's the amount by which the maximum value of the response exceeds the steady state value. So I am looking for amount. Some of you would say that it's the distance. Well, sometimes it can be angle. So you can't really always say distance. But it's an amount that which the maximum value of the response exceeds the steady state.
You can write the value instead of the amount.
You mean this value?
Yes.
Yeah, I probably would accept. Yeah, I'm actually quite lenient. So these 2 months, these 2 months. So what I was saying, please don't think that your exam has no questions that's definition. Not all are calculation, especially recent year. So I flew to Glasgow, and they were saying that sometimes students are actually very good in calculation, but the last part they kind of asked a little bit, and then they discovered they actually don't know what they're calculating, but they got it right. So that last part, recently I get to see more and more insertion of this kind of wording, this descriptive part of it, because they want to test, do you really know beyond just calculation? Descriptive part. If you look at recent papers, you get to see more of that. So part B. Part B has the okay. Now the interesting thing about part B is that if you go about showing this, then you don't get any marks because it says it can be shown. Yeah? It's not asking you to show. Right? So you don't have to show that. It says that it can be shown. Yeah. So it can be shown that this, so we take it, yeah, there is that. So the next thing then is to take all this mass, damping coefficient, and stiffness and put it in there to do the calculation. That's all. So over here, your mass is 5 kilograms. So I'm going to copy down that part, which you do not need to show. Alright, so this C here, that is 30 Newton seconds per meter. This mass over here, that's 5. This K over here, 625. This G, I'm using 9.81. You can use 10, no problem. So put it all in. So I call this equation 1 and this 1 mark. So in this question, you know that the boundary conditions, they are 0. Right? The two boundary conditions, they are 0. When time is equal to 0, that displacement is equal to 0. When, the velocity at time 0 is also equal to 0. If you write that down, 1 mark. Then taking Laplace for equation 1. Right? Taking Laplace for equation 1. After you've done that, you will get xs equal to 9.81 over s squared plus 6s plus 45. Right? Let's do a bit of adjustment after you've taken Laplace for this. Then after a bit of adjustment, you get this. So this one, you need to find out, you need to break it down using partial fractions. And after working out partial fractions, your A will be 0.218, B will be minus 0.218, and then C will be minus 1.308. So if you have this partial expression form, 1 mark, and 3 of these, 1 mark. Certain years they allocate 1 mark per ABC, so ABC altogether 3 marks. But certain years it is 1 mark, depending on that mark allocation. So once you have that, then your XS will be 0.218. I'm going to give you that form. And then the 0.218, s plus 6, s squared plus 6s plus 45. So this form, you cannot do the plus, inverse Laplace. So you need to break this part down into 2 components, something plus something. Do it, and then you'll be able to do inverse Laplace. And you should get this form. So this form is called response of the platform. Right? So you just use words. You didn't say time xt. Is a response of a platform. So you need to understand what is it asking you. So once you have this, if you look at the general form of this equation, So this is for response of second order to a step input, just like in this case, step input. So it should have a general form that looks like that. So that is your underdamped. So if you look at omega d over here, what's the value? 6. So omega d is 6. How about 3? 3 would be zeta omega n, right?